Good to have you on Fascinating Frontiers, episode 63 for May 5th, 2026. The universe has been busy. Let's get into it. Right now, NASA and Roscosmos are jointly assessing fissures that have appeared in modules of the International Space Station. These cracks stem from decades of thermal cycling and micrometeoroid impacts on the aging structure. Engineers on both sides are analyzing stress patterns and evaluating whether targeted repairs or operational adjustments can extend the outpost's life. Ongoing monitoring remains critical to preserving the station's long-term structural integrity. Continued cooperation is essential because the International Space Station is still the only long-duration orbital laboratory available. The open question is how long the current modules can remain safe before major refurbishment becomes necessary. The answers will shape how we keep a continuous human presence in orbit while newer stations take shape. While partners focus on extending the life of our current orbital outpost, new commercial rockets are preparing to expand access to space. Firefly Aerospace plans to debut its upgraded Alpha Block 2 rocket late this summer amid rising demand. Strong demand, especially for national security payloads, is accelerating the Block 2 development. The upgraded configuration reflects the expanding needs of the commercial launch market, where more missions now require reliable and frequent access to orbit. The debut flight will test how the new systems perform once they leave the ground, giving an early look at whether the changes deliver the cadence operators are counting on. As new rockets prepare to reach orbit, lunar landing hardware is also clearing key ground tests. Blue Origin's moon lander has completed a series of tests inside a NASA vacuum chamber that simulates lunar conditions. The successful campaign moves the vehicle closer to readiness for future surface operations. Engineers now have valuable data on how the lander handles the extreme environment it will face on the moon, particularly the thermal and vacuum stresses that will define every surface task. This milestone advances the overall program and brings surface operations one step closer. From the human side of exploration, we turn to a subtle but constant feature of our own planet's atmosphere. Now, here's something that blew my mind when I looked into it. Airglow is produced when solar ultraviolet radiation splits oxygen and nitrogen molecules high above the surface during daylight hours. At night, those atoms recombine and release the stored energy as faint photons. If every square centimeter of the night sky were gathered into a single point, airglow would still outshine the combined light of all visible stars in certain wavelengths. The glow peaks near 90 kilometers altitude, where temperatures sit around negative 90 degrees Celsius and pressures are less than a millionth of sea level. This thin, ever-present shell circles the entire planet and changes in brightness with solar activity, latitude, and season. Yet some wavelengths brighten or fade on timescales that current chemistry cannot fully explain. Why do those particular changes still surprise researchers tracking the upper atmosphere? The answers matter because airglow is one of the few ways we can watch global atmospheric chemistry evolve in real time from the ground. While airglow offers a global view from above, new satellite imagery is revealing dynamic features much closer to home. Fresh NASA satellite images highlight geothermal features around Ahu, Japan, and nearby peaks in El Salvador. The observations support ongoing monitoring of the region, historically known as the Lighthouse of the Pacific. These data add to our understanding of active volcanic systems and how they behave over time, giving volcanologists another steady stream of surface temperature and gas emission clues. From Earth's dynamic surface, we shift to a small solar system body, currently crossing our night sky. The 10th magnitude asteroid 13 Egeria is moving through Virgo this month. Its relatively rapid motion allows amateur astronomers to follow it across the sky in just a few hours. Such sightings provide valuable practice in tracking faint solar system objects against background stars, sharpening skills that come in handy when new near-Earth asteroids are discovered and need quick confirmation. Hands-on observing leads naturally to the kind of patient imaging that captures the changing night sky itself. A time-blended panorama from Dundee Airens captures both the winter and summer Milky Way arches rising above the peaks. The composite image shows how dramatically the night sky shifts over the course of a single night. The technique demonstrates creative ways to document celestial motion and the seasonal change in our view of the galaxy, turning a long night of photography into a single frame that records 6 months of Earth's orbit in one view. Next time, we'll be watching for the first flight data once that upgraded Alpha Block 2 rocket lifts off late this summer. That's fascinating frontiers for today. If you enjoyed this, a rating or review on Apple Podcasts or Spotify really helps new listeners find the show. I'm Patrick in Vancouver. Thanks for exploring with me, and I'll see you next time. This podcast is curated by Patrick, but generated using AI voice synthesis of my voice. The primary reason to do this is I unfortunately don't have the time to be consistent with generating all the content and wanted to focus on creating consistent and regular episodes for all the themes that I enjoy and I hope others do as well.